Sir?
Yeah.
I printed mine out to green pen it. Is that all right?
That's exactly what you should do. Because, I mean, that's exactly what we're doing here today. So if you'd like to take yourself off now and just watch this, and Akshan as well, take yourself off. That'd be good. All right, so here's question 1. So we've got a dice that's been suspected of bias. In other words, it may be a little bit lopsided, which prevents it from rolling properly. And let's look at the results. So this is these are the actual results gained after 20 throws. It wants you to put in the experimental probability. The experimental probability of getting a 1 is not 3. You know that probabilities do not go above 1.0. You can't have a probability greater than certain or greater than 100%. So the chance of getting a 1 actually based on this experiment is 3 over 20. And practically all of you didn't write down over 20, over 20, over 20. So that's 2 marks gone down the drain. It's probability. You know, it goes from 0 to 1, the probability scale. So 3 out of 20 would be 0 point something. Yeah, 0.15, I think. It's 0.015 rather. Yeah. So that's the answers. If you didn't put them over 20, please put it over 20 and get your 2 marks. All right, use the experimental probability to calculate how many times you'd expect a 3 to come up if we did it 80 times. Well, 3 comes up 5 times out of 20. If that was out of 80, it would be 4 times as much you'd expect, surely, yeah? So 4 5's 20. You'd expect 20 3s to come up. Please don't write. Some of you wrote down 20 out of 80. I let it go, but 20 out of 80 is not the same thing as 20. 20 out of 80 is just a quarter. 20 times is what I was looking for. For part C, many of you did the mistake I did originally, and I scrubbed it out. In theory, what would you expect the probability of getting a 3? Well, if you look at this dice here, there's 1 3 out of 6 faces. It's 1 out of 6. Because it's a dice, okay, or a die rather. 1 over 6, not 5 out of 20. In theory, you'd expect 1 out of 6. Do you think this die is biased? You might say, well, yeah, I think I've got too many 3s in the experiment. It should be 3 out of 20 like all the others. Or you can say, no, 5 out of 20 is quite close to 3 out of 20, so I don't think it's biased at all. Both answers are correct as long as you give a sentence to explain. Biased, too many 3s, or not biased because 5 out of 20 is close to 3 out of 20. And it doesn't matter whether you said it was biased or not, but you have to give the reason for it, which is what gets you the mark. That's question 1 done. Any questions about that? Please note probabilities are fractions or decimals or percents, but they're not whole numbers like 3, 3, 5, 3, all right? So there's no questions, I'm moving on. Bar chart, 3 London football teams, 2 consecutive Saturdays, week 1 and week 2. On my exam paper I shaded it because the grade didn't come out very well. I think it came out okay for you as well because I didn't get any crazy answers. How many goals did West Ham score in the first week? I don't know. Week number 1 is the first week. That goes up to 3. How many goals did Chelsea score in the second week? Chelsea in second week. That looks like about 7 to me. Yeah, 7 week is that big one there. How many goals were scored altogether in the second week? Add up the big bars. 2, 3, 7 comes to 12. Clearly I got it wrong before because I wrote a number that wasn't 12 and I just uploaded it and put in a typed number there. Which team scored the least number of goals over the 2 weeks? Well, both these bars are shorter, plus you can do a quick addition anyway. 3 plus 2 is 5, and clearly that alone beats 5, and that's 5 plus the extras, so West Ham didn't have to justify it, just say it's West Ham. This was very well done. What's the probability as a percentage? Well, 0.68. I mean, by this point, you should realise, wait a minute, none of the probabilities are greater than 1. So you could have gone back to question 1 and maybe fixed your work a little bit. So write this as a percent. Well, that's 68%. Now write it as a fraction and simplify it all the way. So 68 out of 100, which is 17 out of 25 for the 2 marks. I should have put a little 1 there, but I didn't. But I included a mark for all of you who got that right. The chance that it will rain tomorrow is 0.68. What's the probability that it will not rain? Just take it away from 1. So you've got a mark for that to show that you take it away from 1. And of course, you get an answer of 0.32, which is the other mark. Yes, I felt sorry for you. Like you got into technical difficulties trying to make this look all pretty and beautiful. It's a lot easier if you just do it in your books directly, really. I know you have to copy out the table, but I'm giving a generous allowance of a lesson for each half, and that's, you know, plenty of time, really. So this is the table all populated with total scores. For example, 1 plus 1 makes 2, 4 plus 2 makes 6. You just fill it all up, and the biggest score you can get is 6 plus 6 is 12. So 2 marks for that. How many outcomes are there? Well, as you can see, I've got 36 results in there. It's a 6 by 6 grid, and there's 36 possible results. I know there's repeats, but there's 36 little boxes which you can populate with an answer. So there it is 36 outcomes. And what's the most likely score? Well, 7, 7, 7, 7. Yeah, the most often score that comes up is a 7. There they are. 1 plus 6, 2 plus 5, 3 plus 4, etc. The most likely score is 7. For part D, you need to look at the English of it. What are the least likely scores? Plural. So you're expecting more than one answer. The least likely scores are the ones that come up hardly at all. Well, there's only one way of getting a 2, 1 plus 1. There's only one way of getting a 12, 6 plus 6. They're the least likely scores, and equally unlikely as each other. All right? So there's 2 answers, 2 marks. What's the probability of getting a total of 5? Well, how many ways are there of getting a 5? 1, 2, 3, 4. Yep, there's 4 ways of getting a 5, and so it's 4 out of 36. What's the probability of scoring more than a 7? So you want all these 8s and these 9s and these 10s and these 11s, and don't forget that 12. He is more than 7. There's 15 ways of getting more than 7. So 15 out of 36, 1 mark. And again, no need to simplify. Venn diagram. Well, here it is. Let's understand what it means. In this Venn diagram, we got students taking part in after-school clubs, tennis and swimming. We've got 18 students who do both tennis and swimming. All right? So these 18 are special kids who go to 2 clubs, the tennis club and the swimming club. So how many attend swimming altogether? Well, it's these 18 who do swimming and tennis, and it's these 17 who do just the swimming. So it comes to 35. Many of you just wrote down 17 because of that number there. No, the whole of the swimming set is all trapped within that circle. So it's 18 plus 17, 35. How many students take part in both clubs? Well, that's the overlap. You all saw that, 18. How many students just attend tennis? Just tennis. Well, it's these 6 guys who just attend tennis, because these 18 attend tennis and swimming. Excuse me. How many students do not attend any of the 2 clubs? Well, there's 5 within the universe of students, and they don't attend tennis or swimming, otherwise that 5 wouldn't be out there. So 5 do neither. How many students are present in the Venn diagram, represented rather in the Venn diagram? Well, if you add up these numbers individually, you should come to 40 something. You do come to 46 in fact. All right. So if you listed the numbers, at least you know what numbers you were about to add. That would have got you a mark anyway. I think, yes, there's a mark there. And 46 will be the total. All right. So that's the Venn diagram question, which means that should have helped you do the next question, we have to do your own Venn diagram. I mean, it's great the way I set it out for you, in as far as if you've forgotten how to do a Venn diagram, then you can see we've got two different sets, we've got an overlap, we've got numbers in each little section, and that should have helped you do question 6. Unfortunately, some of you didn't take advantage of that at all. So here it is, all with my mistakes as well. You're given this information. You've got the universal set representing whole numbers from 1 to 10. That's what integers are, 1 to 10. Set A are the multiples of 2, so it's 2, 4, 6, 8 and 10. And set B are the factors of 24. Now, me being a genius, I overshot it by 2 miles. These are the factors of 24. 1, 2, 3, 4, 6, 8, 12, 24. And then I realised the universe is not that big. The universe of numbers goes from 1 to 10 inclusive. So I then went, go away and go away, all right? So I didn't lose any marks for that if I was doing your test. It's just that I corrected myself and I didn't include those numbers in the answer. As you can see, don't you see a 12 there or a 24? I did originally, but then this is why you have to go over your paper. Once you do your paper, go over it. And I've spotted mistakes. I included 12 and 24, which are excluded from this current universe. So now I'm going to work it out. So I've got the multiples of 2 and the factors of 24, and those who are neither multiples of 2 nor factors of 24. So let's get 5, 7 and 9 outside of the 2 sets first, because they don't fit anywhere. But they do fit within the universe. Why? Because they're all 3 integers, and they're within 1 to 10 inclusive. So who are the multiples of 2? 2, 4, 6, 8, 10. But look, I've got here a 2, a 4, a 6 and an 8. So these 4 multiples of 2 are also factors of 24. So the first thing you should do really is get the overlap sorted. 2, 4, 6, 8. Multiples of 2 and also factors of 24. Then you're left with a single multiple of 2, which is not a factor of 24. You drop it straight into this part of the multiples of 2 set. This 1 and 3, although factors of 24, they're clearly not multiples of 2, therefore they're to stay in this section of the factors of 24. All right? So there's 5 marks for that, including 1 mark for labelling the 2 sets, because you need to know what the Venn diagram is showing you. Let's move on. 2 marks. What is the probability of selecting an element in both sets? I've got here 4 numbers out of a total of 10. So 4 out of 10, or some of you just wrote down 0.4, which is fine. You still get 2 marks. What is the probability of selecting an element in either or both sets? Well, either can mean that bit or that bit. Both means that bit. Basically, everybody inside the 2 sets is included. These 3 outside are not included. As you can see, there are 7 members in one or other or both. So it's 7 out of 10. What is the probability of selecting elements in neither set? Well, these 3 don't belong to either set. They don't belong to tennis, and they don't belong, sorry, it's the previous question, sorry. They don't belong as multiples of 2, and they don't belong as factors of 24. So it's 3 out of those 10 numbers. And then we're going to do section B another day, because it's a lot to take in one go and to make corrections. So please be serious about doing this. You need to make your corrections, because I'm preparing you for year 9. Let's just stop that.